This is our final project on an automated sprinkler system. We decided to do this product because, as you can see, that a lot of American households waste water every year, and we also wanted to find a project that would be something consumers would want to purchase. These are the materials used. We used 2 microprocessors. We used the Raspberry Pi in conjunction with the Parallax propeller board, and set two different types of sensors, a moisture and temperature sensor, as well as an LCD display screen and a relay, 5-volt relay.
Alright, so for my section, I focused on the DHT11 temperature sensor. It's connected to GPIO 25, 3.3 volts, and ground. For the temperature sensor, we use the Adafruit DHT library, and we designed it in such a way that it would contribute to our whole feedback system, so when the temperature is not correct, the system would not run.
I used the DHT11 moisture sensor, and we created a program for that, and then made a user-defined function, which, as you can see, is moisture.callback moisture. It's in the Python code that's in the Raspberry Pi, and what that does is when the system's on, if moisture is detected, it will send message to the screen of the Raspberry Pi saying that moisture is detected, as well as cut the relay off so that you cannot water the grass. And if moisture is not detected and all the other conditions like temperature are met, it will water the grass for the set amount of time.
Next, we incorporated an LCD display 16 by 2. All it does is presents the current date and time when the system is ran, the sprinkler system, and presents the temperature readings that we're taking.
In the following section, we decided to log the data, which is the temperature, humidity, and if we turn on a relay from the web browser, and date and time. We also incorporated an HTML page to where we could turn on the sprinklers from the web page.
Next, we had a warning notification system incorporated in terms that the system might malfunction. So we have a warning system for turning off the sprinkler when the temperature is too hot, or when there is already water detected from the sensor, and it'll send an email saying that the water is too hot, turn off the sprinkler, or like there's water or the temperature is too hot, and it'll turn off the sprinkler.
In conjunction with the email, we also incorporated a text messaging system to let the user know if the relay has actually been turned on from the web browser.
We're going to run a live demonstration showing that our 2 5-volt relays, they're off right now, there's no red light. We will then run the code and show you that when all the conditions are met, the 5-volt relays will turn on for 10 seconds, simulating a sprinkler system running for a given time. The relays are on, given by the red lights. After 10 seconds, they will shut down, simulating the sprinklers ran, given perfect conditions. And there you have it. We have system control that can be controlled manually from the web, and we will now turn on the sprinkler valve relays, which are simulating the relays turning on and off.
Another way we're monitoring the system is pretty much logging every single temperature and humidity. As you can see here, the last temperature was red with temperature, humidity, and none of the relays have been turned on.